Good morning, dear students. Hope you are doing good. And I'm very much confident that you are confident about this unit. That means treatment of works. Dear students, before we are sending, as we are supplying water to public, you must be aware that water is in pure conditions. If you are appointed as an engineer in water supply or water supply board, you are the whole and sole responsible for the quality of water because you are the in charge and you must be known how the water is being treated and what are all the different technologies that are available and also adapted for that respective water treatment works. Hopefully, you all are well content with the technologies for various stages of water treatment. That means sedimentation, coagulation, filtration, and all. And we also learn how the water plants or treatment works are designed. For designing the basic steps, we must consider they are all the units must be constructed in a sequential order. All the units, that means here every unit is clearly indicating the stage of water treatment. That is the reason all the units must be constructed in a sequential order. And also the water must be flow and gravity. Likewise, the elevation has to be maintained. Proper plan has to be adopted and there must be a feasibility for future expansion. And there should be a good ambience with respect to atmosphere in and around the treatment works. And there should be space for staff quarters so that the monitoring will be in continuous mode. In the previous class, that means in the filtration topic, we have seen both the type of filter beds. One is slow sand filter and the other one is rapid sand filter. After that, we also seen the basic steps to be considered while we are designing, or else basic aspects we must consider at the time of designing sedimentation tanks. One more time, I would like to have a look, or else I would like to discuss about those aspects to be considered at the time of designing sedimentation tanks. After discussing, we'll go to a problem which you may expect in your examinations. See, after we are discussing the basic steps in sedimentation tank, that means for the designing of sedimentation tank, where we have seen 4 stages: an inlet zone, settling zone, sludge zone, and outlet zone. So other factors to be considered: velocity of flow. What is the velocity of flow? Here, the velocity of flow in water should be sufficient enough, which causes or through which the hydraulic subsidence of suspended impurities will be observed. And in one word, the velocity should maintain or else should remain uniform throughout the tank, and normally it should not exceed 150 mm to 300 mm per minute. The flow, it should remain uniform. Velocity of flow should remain uniform and it should not exceed 150 mm to 300 mm per minute. And the other one is capacity of tank. The capacity of tank can be calculated by considering one is detention period and overflow rate. See, what is the detention period here? The theoretical time that has taken for a particle of water to pass from entry to exit of a settling tank is known as the detention period. And it has been, and it can be calculated with the formula C equal to Q into T, where C is capacity of tank, Q is discharge or rate of flow, and T is detention period in hours. The detention period normally depends on the quality of suspended impurities present in the water. Normally, for plain sedimentation tanks, the detention period will be found, will be vary from 4 to 8 hours. What is detention period here? The time that has taken for a particle to pass from the exit to, sorry, from entry to exit of a settling tank. The time that has taken to pass the particle of water from the entry to exit of settling tank. Normally, it will be calculated with the formula where C equal Q into T. C capacity of tank, Q is discharge or rate of flow, and T is the detention period in hours. Normally, for plain sedimentation tank, the detention period is vary and it will be from 4 to 8 hours. Now, we have seen, now we'll go to a look, we have seen the inlet zone, settling zone, sludge zone, and outlet zone, and also we considered, we discussed about velocity, capacity of flow, inlet and outlet arrangements, shapes of tanks. We have seen rectangular tanks, circular tanks, over bottom tanks, and other considerations. So now we'll discuss one nice problem which you may expect, that is, see, of course, overflow rate. See, overflow rate can be calculated, and overflow rate, this is already we discussed. This is already over, but one more time, I'd like to reconnect to we'd like to make you to reconnect the topic, what we are going to discuss now. The detention period, T, distance of the descent by velocity of descent, but T equal C by Q, and from 1 and 2, we discussed this is already, and finally, we came to notice that surface overflow rate V equal to D to Q by C, and it is ultimately speaking Q by L into B, where L is length of the tank, B is breadth of the tank, D depth of the tank, capacity of tank, detention period, discharge rate of flow, velocity of descent of particle to the bottom of the tank. Now, we'll discuss a problem. This is already we discussed the capacity of tank in the previous class itself. We discussed what is velocity of flow, what is detention period, what is overflow rate. Now, I'm going to a problem which you may expect. Take all of you, please take the calcs. If you are unable now, at least after the class, you may go for rewind and try to learn this problem, and you may expect this type of problems in your examinations. What they are given now, let us see. At waterworks to purify water, whose daily demand is 9 into 10 power 6 liters per day. For that capacity, we have a question: design the sedimentation tank of the waterworks fitted with a mechanical sludge remover, and assume the velocity, flow velocity is 24 centimeters per minute, where the detention period is 8 hours. We have a clear information about the quantity of water, that means the daily demand, and about the sludge remover, that is a mechanical sludge remover, and the flow velocity is 24 centimeters per minute, and the detention period is 8 hours. We have four types of information. One is the water demand, other one is mechanical sludge remover, third one velocity of flow, and fourth one detention period. Now we'll try to solve this problem. The first step, quantity of water to be treated in 24 hours. See, once we are supplying, the water demand is 9 into 10 power 6 liters per day. That means we are not supposed to send the water directly. As I said that even at the beginning of this session, we must treat that water. How much of water we must treat? The water that is in demand has to be treated. That means 9 into 10 power 6 liters per day. Okay. Next, quantity of water to be treated during the detention period. When we can treat this? Normally during the detention period. What is the detention period? Is 8 hours. So 9 into 10 power 6 by 24 into 8. What we'll get the answer? Please take the calcs and do it. What is the answer? 3 into 10 power 6. I can say it as 3 into 10 power 3 meter cube. And I can write it as capacity of sedimentation tank required is 3000 cubic meters. How we got? Simply into 8. Why 8? Because the detention period is 8 hours. Hope you all got the same answer. Hope you all got the same answer. Understand? Next, velocity of flow. Next is velocity of flow. Is they given? Yes, velocity of flow. How much they have given? 24 centimeters per minute. Is the same I mentioned here? Velocity of flow is 22 centimeters per minute. Now I would like to convert it into meters. See here, meters. So it will be 0.22 meters per minute. Now, hope you got how this value came, and hope now you got how this value came into the picture. Now, the length of the tank. Now we are trying to find out length of the tank. What is the question here? Design the sedimentation tank. For designing sedimentation tank, we need the length of the tank normally. That is the formula is velocity into detention point. What is the velocity of flow here? 0.22 into what is the detention time? 8 into 60. Take the calcs, and I'm confident that your value is 106 meters. Now we got the values. Capacity of sedimentation tank, that is 3000 cubic meters. Flow of velocity we just converted from centimeters to minutes. By using this, we are able to find the length of the tank which we got 106 meters. Understand? Now, after we'll move forward. Area of the tank that is required. We got the length, we got the capacity that is required, and now we need area. Area of the tank. The formula is capacity of the tank by length of the tank. What is the capacity we got? 3000 cubic meters by length of the tank. What is the length of the tank here? 106 meters. Let's take the calcs. 3000 by 106. That is now square meters, as 106 meters and 3000 cubic meters, that is 28.3 meters square. Now we got, up to now we got area of the tank, we got a length of the tank we have, and we found the capacity of sedimentation tank. Now we'll go to the Depth of the tank. Normally, see, have a look here. The depth is not mentioned here in the question. The depth is not mentioned here. The depth is not mentioned. Did anywhere found? Did anywhere found by you? No. So if the depth is not given, we must assume how much. You're not supposed to assume as per your wish. You're not supposed to assume as per your interest. There is an empirical. There is a pre-prescribed. If the depth is not mentioned, you must take the depth as 3.5 meters, as it is not given. So now with the depth, we'll try to find out width of the tank. A width of the tank, we got the depth, we got the area, we have the length. Now we want width. How we'll get? Normally width of the tank will be find out by area by depth. What is area here? 28.3. What is the depth that is assumed? 3.5. Now the width will be, take calcs and do it. We may get it 8.1 meters. Now see, as the depth is not given, we assumed and 2 as 3.5. One more thing you must do when we are trying to design the sedimentation tank, you must also consider freeboard once if they are not given. If they are not given, you must take into the consideration of freeboard. Normally that is 0.5 meters. We're not supposed to assume the freeboard as per your interest, as per your wish, or as per your interest. You must take the freeboard. If they're not given, that is 0.5 meters, and that must be added to the depth of the tank. What is the depth of the tank we have taken? 3.5. Why we have taken? It is the empirical figure, pre-prescribed 3.5 meters. To that freeboard we are adding, finally that will be 4 meters. Depth will be 4 meters. Now we are just adding all the dimensions. Now the required sedimentation, now that's we got the values of capacity, we found the area length, area, and width also. Now see here, length of the sedimentation tank 106 meters, and width of the tank 8.1 meters, and depth is 4 meters. For what? To treat the daily demand of 9 into 10 power 6 liters per day. What is the question? Sedimentation tank. Did we got everything? Yes. We have the length. We have what it is? Width. We have the depth also. Hope you understood. Like this, we'll find out, we'll design the sedimentation tanks. See, what you should remember, if the depth is not given, we must assume it has 3.5 meters. If the freeboard is not mentioned, we must take it as 0.5 meters. See, this is the question where we got the values of water demand, 24 centimeters per minute, 8 hours. Why 8? During the detention of period, normally treated author. That is, what is detention period? The theoretical time that has taken for a particle to cross from the entry to exit of the settling tank. That is called as detention period. See here, we can treat the water during the detention period of 8 hours, and the normally as 9 into 10 power 6 per liters per day. That means 24 hours. That means here detention period is 8 hours. So by 24 hours into 8 hours, where we got the capacity 3000 cubic meters, and the flow is just given in centimeters, we are converting into minutes, 0.22 meters per minute. Length of the tank is 106 meters. How we got? Simply velocity into detention time. 8 into 60, 8 hours into 60 minutes per hour, 60 minutes. So it is 106 meters. So it is minutes, and here 8 into 60 minutes. See, as we converted it centimeters into minutes, it comes as 0.22. Now you are clear, you are very much confident how we got this value. Now area is capacity by length. Capacity 3000, what we got here, and the length is 106, and we found 28.3 meters square. Assume the depth, as they are not given, we just take in test 3.5 meters, that is pre-prescribed and empirical. Width of the tank is area by depth. What is area? 28.3. And what is the depth we assume? 3.5. Now we got the value 8.1 meters. Freeboard, this is a pre-prescribed 0.5 to the depth. So 3.5 plus 0.5 is 4 meters. Now the sedimentation tank is ready, and the dimensions are 106 meters, 8.1 meters, 106 meters of length, 8.1 meters of width, and 4 meters of depth. Now the sedimentation tank is ready to treat 9 into 10 power 6 liters per day. We got the answer. What is the question? Design the sedimentation tank of the water works fitted with a mechanical sludge remover. For what? Where the water daily demand is 9 into 10 power 6 liters. Hope you are very much confident. Hope you understood. If you have any doubt, please contact me. The domain, whatever you feel flexible, either message or phone call or mail. Thank you.